Assalamualaikum and good day. My name is Dennis Zaidan bin Azhar. I'm a metric AF190182 from Section 5 Foundation Engineering. Today I will discuss about the soil improvement, which is the stone column. The content of this video is introduction of stone column, applicable soil types, benefit of stone column, equipment and material use, and the last one is procedure of design. The first one is introduction of stone column. Stone columns is a soil improvement technique that reinforces the soil with a network of stone compacted columns. Like most soil improvement techniques, stone columns are used to reduce settlement and increase load-bearing capacity. They also accelerate soil consolidation as a result of the drainage capacity of the granular material within the columns, which act as pore of water pressure evacuation points. Next, applicable soil type. The first one is gravel and sand, less than 10% silt, no clay. Number 2, sand with between 10 and 20% silt and less than 2% clay. Number 3 is sand with bigger than 20% silt and non-plastic silt. The last one is clay. So all 4 applicable soil type have own densification and reinforcement. Stone columns are best suited to sandy soil. A greater concentration of stone columns are required in siltier soil. So, for the benefits of stone column, number 1 is provide the soil with an increased drainage path to help reduce excess pore water pressure that can lead to liquefaction, so the columns can reduce the consequences of liquefaction when this occurs. Number 2 is no dewatering or excavation is required for the construction, and they typically have a short construction period. Number 3, improve the resistance of cohesionless soil of liquefaction by several mechanisms. The last one is prevent sinkhole from pre-collapsing in karst regions. We move to the equipment and materials. For the equipment, stone is fed to the vibraflood tips through a trimmy pipe that is affixed to the side of vibraflood. A front end loader fills a stone skip with stone on the ground, and a different cable lowers the skip to a chamber at the top of the trimmy pipe. Vibro piers are an application in particular. Spaced stone columns are used in the procedure. In cohesive soil, where a pre-drilled hole may be digged to its maximum depth and remain open, vibro piers are often built. For the materials, although the natural gravel and pebbles have been utilized, the stone is often a hard rock that has been graded and crushed. Next, we move to the procedure of stone column. We use the bottom feed system. The bottom feed system involves feeding of stone aggregate via a trimmy pipe along the vibraflood and with the aid of pressurized air. The bottom feed method is preferable when the soil is highly collapsible and unstable. The BFI system controls the length and the diameter of the stone column better than the top feed system. In addition, there is no risk of soil collapse when stone is released because the vibro length is not withdrawn from the ground until the stone column is finished. The first one for a procedure, with the vibro cord stabilized on hydraulic outriggers, the leaders are elevated to the vertical and vibrator located on the ground at the stone column position. The skip is charged with stone. Number 2, the skip travels up the leaders and automatically discharges stone into the reception chamber at the top of the vibrator. Third one is the vibrator penetrates the weak soils to the design depth under the action of the vibration, compress air and pull down with facility. Number 4, at the required depth, stone is released and compacted by small upward and downward movement of vibrator, pull down being employed on the downward compacting action. The last one is with stone being added to the system as necessary at any stage of the construction procedure. A stone column of very high integrity, tightly interlocked with the surrounding soil, is built up to the ground level.